Hey folks, hello. Today we are going to talk about how to manage cardinality. We are going to see a live example. Aniket is going to show us. So I have Aniket with me. But before we start, I'll just introduce myself. My name is Prathamesh. I work as a developer evangelist at Last9. We build tools around monitoring and observability. Today we are going to see an interesting capability that Aniket is going to show us. Aniket, you can introduce yourself and tell us what we are going to talk about today.
Hi, I'm Aniket. I work with Prathamesh in the developer relations team at Last9. Mostly these days we have been exploring or other taking up streaming aggregation and high cardinality use cases around Levitate and just taking crossing it to the limits of what Levitate can operate. Again, this is something that we have other users also who want to give that feature a shot. Do get in touch with us. We'll help you out with the setup and everything, and you can test out Levitate. Again,
So
that's what
Aniket,
we've been up.
yeah, but what is Levitate? Maybe people, not everyone might be knowing about it. So what is
Okay,
Levitate?
so so Levitate is a time series database that we have built from ground up with uh, with more capabilities around uh, high cardinality as a primary feature of it, where storing high cardinality data is certainly possible. What that helps from a observability use case is that you can go into deep monitoring. That means with more label sets and more samples you can ingest, and
Mhm.
given the metadata that you can include in label sets, that gives you the depth of observability. So it unlocks that, and again, using streaming aggregation and other features of Levitate, it certainly supercharges your observability
So
needs.
I have one question, Aniket. I think it might be interesting to talk about high cardinality. Like perhaps you can show us a demo how you can like run into this high cardinality situation, and also talk a little bit about what does high cardinality mean in terms of these metrics databases.
Got it. So yeah, let me just share my screen.
And folks, feel free to add any questions as well. Yeah, we will take those as we speak. So the idea is basically to keep it um, a conversation. We basically will be able to take any questions that you have as well. So Aniket, I have added your screen to the stage. Perfect. Yeah, we can see it.
Got it. So yeah, high cardinality is a problem that is very common in time series databases that you may use these days. So how that problem occurs is when you have high volume of metric data with an incredibly high amount of label sets in it. So when that happens, you what happens is that event is called a cardinality explosion. Now this when you are ingesting that sort of data, ingestion will not be a problem, but the problem primarily arises is when you start querying that data.
Hmm.
Is that is when you suddenly realize that, oh, I'm not able to query all the data that I've ingested because the time series database cannot perform a scan to even answer the or return the query result. So that is when you, that is one situation or the most common situation where you feel that you have arrived
Hmm.
in a cardinality explosion, or your cardinality has
So
been exploded
Aniket,
at that. Yeah.
why this cardinality is important? Like, why do you think this is a important factor for people to consider? Like, can they just get away with not having high cardinality?
Uh, it really depends on how much, the depth of observability that you want and what you desire. So, if observability is not that paramount to you, then certainly you can get away with not ingesting, or rather not querying that amount of data. But when businesses run at scale and the more reliability matters to you, that means the data that you generate from applications and telemetry data that comes out. It gives
Mhm.
you more and more depth of the applications. I mean, the observability around your applications that you use. So
So
multiple use
perhaps I think
cases.
what you're touching upon, right. I think perhaps what important factor you're touching upon is also, I think, not just looking at it from an infra perspective. So infra monitoring, a lot of people use Kubernetes these days. Tracking pods, instances, container IDs, right? Those become your labels, and there will be always like not just 10 pods, right? Like you will have hundreds of pods, 500 pods, 1,000 pods at times,
Exactly. Yeah.
and because these are ephemeral infrastructure, their IDs, their label values will constantly keep changing. So that is, I
Absolutely.
think, one source of this cardinality explosion. But I think one other interesting point that is important is also when you start thinking about tracking business metrics or product metrics. Let's say you have a B2B SaaS application and you want to track the performance of the API per tenant,
Per
or
tenant
even
API.
correct. Or even if you want to track the performance across a cluster, a physical cluster, or a data center, those labels will basically multiply all the other existing labels that you have, and that will probably result into your cardinality going beyond a certain limit. I think once we establish that this is not really a problem, because if you think about high cardinality, a lot of times we think about it as a problem itself, but it is actually a way to answers in a lot of ways, right? Because it can
Correct.
actually give us a lot of information about how our system is behaving across those dimensions.
It's sort of a
I think one other
limitation or a
interest,
roadblock.
yeah, correct. But I think one other interesting point that is very interesting to talk about is how do people handle high cardinality today? So, based on your experience, based on what conversations you have had, what do you think is approach that people take to handle this high cardinality?
So yeah, so fundamentally, based on experience, it's the first thing is that you drop the data. Eh, if at possible at before ingestion, you can just drop it. That's one of the common practices. The other more cumbersome practices where we've seen that changes have to be made in instrumentation, where people have to go
Right.
and make changes in their code base and reduce the number of label sets that they send in their metrics. So these are one of the two ways that are the most common use cases of how people deal with the cardinality situation and ergo make a sacrifice in their observability needs. So they truly desire the observability, but because this roadblock or this limitation comes in the way, people don't really get about achieving the true desire of the in-depth observability that they want.
Yeah, and I think one of the important point to consider here is also like pros and cons of both of these approaches, right? Like while you can say that bumping up infrastructure is in a way good, it also affects your cost because it is ultimately going to
Absolutely.
increase the amount of resources and money that you are going to spend on it. If you change the instrumentation, it means that you're basically not going to have access to that information, and that puts a limit because even if you want to track it tomorrow, today maybe you don't need it. Tomorrow, if you want to track it or track certain other attributes, you have to go back, change the instrumentation. And we all know that deployments are
Yeah,
hard, right? Like every time you change
exactly.
the code, that means that you have to redeploy, you have to go through all the flow again. And that also becomes tricky to keep changing that. Cool. I think that sets a nice ground in terms of the understanding what high cardinality is, how people look at it today, how people sort of try to solve it. But what do you think? Like, are there any other points that you would like to discuss before we jump into how to address high cardinality?
Uh, we can jump into the demo that we have prepared for the audience, and
Sure.
while
Okay.
doing the demo,
Yeah. All right.
explore. Yeah,
You can share. Yeah. we can talk about that. So let's go through that. Let's share the screen. And
One second. Is my screen should be visible?
yeah,
Is
I'm
it?
adding it to the stage. Yes.
So yeah, I think we have this. I mean, suddenly out of nowhere, you're seeing a dashboard. This is called a high cardinality dashboard, right? I just wanted to kind of give some context on what is the data that we are looking at and how exactly have we solved a high cardinality situation using some of Levitate's key features, right? So, as you can see, we have uh, throughput coming of a certain application where we've kind of added, or rather, the rate at which we are getting is we're getting about 100,000 samples per minute. That's sort of the rate at which we are getting traffic, right? Now that is split. Throughput is split between a tenant and a service, and we've added two queries over here
Okay.
that run. Yeah. So let me just quickly show you what we are looking at. So this is a very basic query. So I have an application. I'm just getting the count of total samples. Now, given 100,000 samples, we've kind of desired. Our desire was to have a service, the total throughput of a service, and also the total throughput of a tenant. So that is what
Hmm.
this dashboard represents. Again, very straightforward query.
This is, I think, very typical red metric setup, if I understand it correctly, right? You're
Exactly.
basically
Yeah, yeah,
instrumented probably an API, which is emitting these
yeah.
red metrics. Throughput is one of the example that we are showing here. But essentially, I think the throughput and the total samples is the count of the original metric. Like those are the sample points that we are collecting.
Correct. Yes. So
Got it.
now,
Okay. What
and
is the
also
time it takes to run that original query?
exactly. I was just getting to that. So just to add some a bit of context, right? As you can see, these two queries are just the aggregation of the main metric itself. So I have
Hmm.
run a query over here. Let I just walk you through the query. So I'm just summing
Hmm.
it by a label set, and I've ran a what do you call a rate counter over it, and it basically it's just a metric with a filter, right? Now turns
Right.
out that runs
It
so
takes around
this query.
1.29 seconds though.
Yeah, yeah, yeah. So these two queries literally took quite a while. 1.29 seconds is
Yeah.
very, 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 very huge for a very basic query like this. Now, given
Hmm.
100,000 samples, this query has to run against that and give you back the result. And like this, I have two queries.
Yeah.
Now, what
And
we
maybe
also
like
have
multiple people create these dashboards, right? And if they have same
exactly.
panels, this will be again and again repeated.
Absolutely. Now, again, in a standard developer setup, right, in an engineering team, you have a minimum of five people accessing dashboards and counting
Yep.
upwards, depending upon size of teams. So, the number of browser sessions of these dashboards that are open when they reload, these queries get hit to your TSDB, and it equally will result in higher latencies for you to even fetch this data, no matter how simple
Hmm.
the query you have. Now, this becomes a very huge challenge when you are in situations where you need your dashboard to be responsive as a very basic need. That, hey,
Yep.
given my system or my production system is undergoing incident, that's why I come here and explore for some patterns, or I'm looking for some insights from the traffic that I see. So, to even
Right.
unlock such basic needs, it is taking a while for your dashboard to even load. And this is a very, very classic problem. Prathamesh, I'm sure you also
Yep.
would have encountered this situation a lot of times.
Actually, the problem with this is I don't know what to do. Right.
Yeah.
A lot of
So,
times this happens, but the uh, I'm sort of used to it in ways, right? Like, okay, some dashboard is going to get slowed, and maybe I'll just reload,
like,
maybe I'll just reload, maybe I'll just reload,
wha-
which
one of
actually
the
behind the
one of
scenes,
the craziest
yeah,
hack that I have done is that I've gathered people around and opened it on one screen. So everyone shut off
That is not
your
unheard of. So I remember one story, and this was, I think, a couple of years back, when we were discussing like we were doing a pilot with one of the customers, and they basically said that during a critical downtime event, their engineering head basically called all the people who were like looking at the SRE, like the Grafana dashboards, and told them to basically join one call, and then he opened that Grafana dashboard
yeah,
and asked everyone to basically not even touch it at all. I mean,
correct.
to
Yeah.
solve the problem of slowness. But yeah, this is pretty common.
But
The
yeah,
essentially
but
the
again,
problem with this kind of, yeah,
then go ahead, go ahead.
yeah, the problem is, oh, firecrackers are already here. Diwali has started. That's great. But essentially, the problem is what to do next. I don't want to really change my instrumentation because I want this data, of course, right? Maybe I will bump up resources once or twice, but that may not be an option always. What I perhaps
Correct.
need is a way to do it in the real time itself, if possible, because that is something that can allow me the flexibility that, as per my use
Correct.
case, I can tweak the result and then create these streams in real time.
Yeah.
Yeah.
So exactly right. So if instrumentation changes are not possible, and rightly so, it shouldn't be dealt at that end. It should be the last resort. Instrumentation changes. So
Yeah.
also you can't perform or add a recording rule or something, because recording rule itself will query the database and then create a new metric. So we want to
Oh
have
yeah, that is
a
also a problem because that will perhaps put load even more, right? Because maybe it will
exactly.
query the data after the storage. Yeah.
So it's a double-edged sword, right? You may get the new metric, but to produce the new metric, it has to also query again. So you're running around in
Yep.
circles. For me, I look at it as a cash 22. Like,
Hmm.
if the main data never loads, then what is the point of a recording rule that is getting triggered every now and then,
Makes
just
sense.
choking the system? So that is
Hmm.
so. Given these two solutions that are commonly tried, one way to think about is that what if there was an ability where we could in real time uh, make sure that we can declare some levels of rules or aggregations or whatever, and let the
Hmm.
data pass through that and then be stored. Very similar to recording rules, but slightly different in terms of where it is positioned in the whole data pipeline of metric, uh, the whole metric lifecycle, right? So it has to be right
Hmm.
after implementation, but right before ingestion. Would that be
Hmm.
a like?
Okay.
What do you think about that sort of an approach?
I think easier to imagine, harder to actually
Yeah,
implement it, right? Because there are two critical factors that come to my mind when you want to think about that, and that is uh, when you say real time, it has to be real time because if the pipeline is down or has lag, that means your data is incorrect because the original
absolutely.
metric might have moved forward, whereas what you're trying to say using the aggregation, it might have lag, right? That is one.
Yeah,
And the second is, I think, also around accuracy. Because if the data is not accurate, then I'll not trust it. So that is also one of the critical points. So while the idea is great and idea is quite intuitive, I feel that the engineering side of implementing it is not that straightforward. You need highly scalable pipelines to basically support it at do it at real time.
correct. So I mean, surely, by the sound of it, it seems like a very complex setup, but that is what I'm here to showcase to everyone, that this really isn't that complicated. Actually, it is the most simplest approach to deal with this and yet get every benefit that you are looking for in terms of
Hmm.
handling high cardinality data, or rather exploring and leveraging your metric data more. So one of the ways that
Hmm.
we can do is by declaring something known as streaming aggregations. Streaming aggregations is a feature of Levitate where we can declare PromQLs and the resultant metric that we want out of its execution, and that metric and the value ends up being finally stored. So you're storing
Okay.
something that you 100% know that this is the final value that I desire and I will always query. Those declarations get evaluated and the final value with the new metric gets stored. So imagine that if you're like suddenly over here I see 100,000 samples that I'm getting, but what I purely desire in this dashboard is I just want to know my service throughput and my tenant throughput. Rest everything is immaterial to me. So at the end of the day, what
Right.
I want to query from my database are just two metrics, right? So
Hmm.
that
Or
should be the
two
only
attributes of that metric.
exactly. So those should be the only things that I need to be storing. Now imagine out of 100,000, my use case has come up to two. Everyone else who I encourage
Oh,
you in
so
the
that
moment
two that we wait. So are you saying that two aggregated samples count that we see there is the result of aggregated aggregation?
yes, yes,
Okay, so from 100,000 we have gone to two.
absolutely yes. Now the two is a
Interesting.
use case of mine.
Yeah,
So I just
it
want
may
to
change. Like
yeah.
I
There are
may
obviously
have
things that desire.
40, 50. Makes sense. Yeah.
Exactly. Yeah. But what really I'm more emphasizing is that the more use cases that you can think of in terms of aggregation data, right? Now, think of it this way: dashboards are already aggregated in terms of queries, right? What if you take the same queries and just apply it before it ingestion, or rather before storage,
Hmm.
right? So
Hmm.
they finally become the final metric that you want to query. So thus, massively you
Hmm.
reduce the samples that you ingest in the first place. So that is
But
the
what
power
if
of
I have to, right? I get that point. The question that I have is, what are those two charts that are below? Service
right.
throughput and tenant throughput. I understand the
Got
aggregated samples. You talked about the total throughput earlier. What are
correct.
those bottom charts?
Got it. So bottom charts are again a metric that I have created based on streaming aggregation, and now I'm just querying these metrics. So let me just quickly
Okay, so it is the
showcase.
streaming aggregated metric. Okay,
Exactly. So now you can see that I have just one metric that I've called my app service throughput. Okay, this is one metric
okay.
that this one panel is querying, and more
Hmm.
importantly, uh, you can also see that it got executed in about 472 milliseconds, right? That's just one query.
Hmm.
Okay, at the
Hmm.
same time, this also will be sort of a very similar query, right? Tenant throughput under 500 ms, right? Little over 500 ms, whatever. It is still faster
Right.
than a second or
Hmm.
a second or more. So now you might be wondering that
Yeah.
how did this happen, right? Like from
Yeah. From
where
where
have I
did you
gained
get this metric?
exactly? So this is not there is no magic here. It is a simple declaration that we can do. Now here is where I'll go and show you where in Levitate I have declared this, right? So I just come over
Hmm.
to my Levitate clusters again. Yeah, so I am currently sending data to a demo cluster in Mumbai region, right? So I'm going to come here
Hmm.
and come to settings. So Levitate has a provision for streaming aggregation over here. Now, as you can see, I have just declared this is a YAML declaration. I have just declared a prompt query. Now the prompt query is nothing but the query that my dashboard used to run before. If you see, this is very
Right.
similar to the query that we had over here, or
Oh
rather,
yeah.
it's the same.
Right.
So I have just copied that query, pasted it over here,
Hmm.
and I've just
Hmm.
said that okay, this query should be evaluated and should be queried as service throughput. And similarly, I have
Got
created
it.
one for tenant throughput. Now, this in
Hmm.
the pipeline of data ingestion, metric data ingestion, it will store these two new values with the aggregated total net value of the metric itself. Like whatever the query was, its resultant value will be stored against this new metric name. That's all
So
that we need
basically,
to
it
do.
will create these two metrics, right? It will
Exactly.
create these two metrics. And that's what we
Absolutely.
see on the Grafana dashboard.
Correct. Yes, that is what we wanted and that we have. But more importantly, Prathamesh, you said that I also wanted these two queries, or rather, there is no complex engineering that has to happen, or in, like, you don't have to set up anything. It's as good as declaring
I mean, I don't have to set it.
two
As
lines
long
logic.
as you are doing it with Levitate, I'm fine. I don't want to
Exactly,
run
right?
it or set it.
Exactly. So
As a
addition, you
user,
are
I'm
never
not
running
interested.
anything.
Yeah.
Exactly. It's just a small feature, but does quite powerful things. That way, now I can
So
create
questions.
independent
Can
tables
you?
and just set those queries. But
Yeah, I
one
have
point that
few
you
questions.
highlighted was that, yeah, do I see any latency, right? Again, what's the point
Yeah.
if I aggregate, but it is late? On this aggregated metric, if I'm setting alerts,
Yeah.
but if that
Yeah.
aggregation is lagging, then it beats the whole purpose, right? I'll go back to the latency that I had before. I mean, so again,
Mm,
these are very very key things that don't happen when it comes to streaming aggregations. So I can just quickly show you.
mm,
Like, let me just reload the dashboard, right? So right now we are at
okay.
9:58 p.m. So you can see
Mm,
all of these dashboard will suddenly load. See, this dashboard was, the total throughput took a bit of a time, but these two loaded
yeah.
instantly. But
Yeah.
both times, right? The data that we got as of this minute is exactly the same as what we had over here. See, 16.1 uh,
Mm,
million pounds per minute, and over here also it's the same thing. So there is no data loss.
mm,
You're not losing out on anything, but also
mm,
it is real time and fast. So these
very
two
interesting.
additional things that you spoke about also get checked off when it comes to implementing, or rather leveraging, streaming aggregation with Levitate.
I have few questions on the way you created those streaming aggregations. So perhaps you can go to the settings. Now,
Yeah.
you mentioned you put the PromQL here directly. Does that
Yes.
mean I can put any PromQL here as a PromQL query?
So yes, you do have to adhere to certain PromQL restrictions. Basically, one of the things is that you don't want to run rate queries here. Rate queries, you may want to run it on the evaluated uh, metric, that the final metric
Metric.
that gets stored. That is one key thing.
Mm,
But more of such slight, what do you call, best practices, I would say, we have documented as
mm,
part of our docs over here.
okay,
So
got
also
it.
we've made a list of all the, let's say, supported PromQL functions that are natively used, right? But also some
Mm,
good ones as well, such as sum2. Sum2 also helps
mm,
for counters, and it takes care of the reset part of it. So these things are
mm.
also first class handled by Levitate.
Understood. Interesting. And I just have to define a PromQL and that's it. So I can define such any PromQL. I can give it a name, and then click save. Is that what I need to do?
That's about it. Yes. So when you
Very
apply this
interesting.
for the first time, a certain, like, it will take about a couple of minutes for it to for the aggregation to apply. But after that, it's just smooth sales. So no, there is no
I
lag or
see
anything
one
that you must
problem.
actually.
Yeah, but Aniket, I see one problem with this. Maybe with two people accessing it, it is fine. But if I have a larger team, accessing it from just the UI editor might be tricky.
Oh, so for that we have, again, give, this is a dev tool. This is for developers. So one of the best friends of developers is nothing but GitOps, right? So streaming aggregations
Mm.
can be declared using GitOps as well. So you just make a commit and
Oh, okay.
leverage the power of Git as well, so that you know what changes you've made in the past, and it stays on. So
Got
any,
it.
if you have a lot of declarations, it's obviously better to
Mm.
use GitOps pipeline, which again we help set up, and we helped all of our customers also set up at last name.
Interesting. Okay, so it also allows the GitOps pipeline where I can just
Yeah,
send pull requests, they get merged and get deployed. Very cool.
exactly.
That's amazing. How do I get started? How do I get
It's
started
quite
with
simple.
this?
You just go to the sign up link. If you have a GitHub account, it's more easier for you to go and get started. If you're an org, just log in via Microsoft or your Gmail and sign up. And it's so simple that when you just launch a cluster over here, you will enter into this workflow. You just select the region that you want to operate in, define a cluster name. Ideally, speaking from best practices, if you're running multiple Prometheus instances, separated by clusters, separate cluster, and declare more clusters for prod staging. So these separation becomes nothing but a click of this thing. Think of it as
Mm.
bringing up EC2 instances. It is as simple as that, or RDS. It's exactly same. So you just create after that you'll get your remote write URL, put that remote write URL in
Mm.
your existing Prometheus configuration, and boom, after that data will start coming in. And again, you can either leverage the explore option in Levitate, which is nothing but the Grafana that you're used to, or if you have your own
Mm.
internal Grafana that you're running, you can go ahead and add Levitate as a data source and get on with your day. So dashboards at your end require no changes. You can parallelly also write and check that okay, I have two data sources. One is Levitate and one is my native Prometheus. You can do a parallel roll off as well, like slowly, staggeredly roll off Prometheus and bring on Levitate. So all of these are highly thought, like these are very well thought through in terms of developer and SRE workflows that we don't want to bring, because if it causes breakage, then it ends up being more work, which we this process entirely avoids. So very simple data source, just add and get on with your day. No changes required.
Cool. I think this looks very interesting. I think we should share some resources of this. So I'll do that after the session. I'll share some of
Absolutely.
the getting started links that you shared in the comments as well. If somebody wants to give it a try, they can just sign up and start sending data. Uh, Great. All right. Aniket, thanks a lot. I think this was really helpful. And we got a great, like we got a clear view of how to use streaming aggregations to manage high cardinality metrics. So that is great. We'll come back
Yeah,
next week, perhaps, or in few days with other things.
yeah. Post Diwali, of course.
Yes, post Diwali
Yes.
will be back with one more capability, one more story to talk about, right?
The other thing is that, of course, feel free to ping us on Discord. Prathamesh and I hang out
Yes.
there. So if you're setting up streaming aggregations, you want to run your ideas on how you want to do it, more than welcome to have those conversations and help you get clarifications or whatever. Even if it's basic Levitate support that you need, happy to come and help you guys out.
Yeah, definitely. I'll share a Discord link in the chat as well. But I think that's all what we have for today. Let's wrap up and we'll come back after Diwali with one more demo about Levitate. Feel free to
Absolutely.
ask us any questions, as Aniket said. Just reach out to us on Twitter, LinkedIn, or YouTube, or Discord, wherever you want to reach out to us. We are available and would be very happy to know how you handle high cardinality. Is it via some other mechanism that we missed discussing today? Would love to know that and would love to learn from that. Thanks a lot, Aniket. Thanks a lot for your time.
Thanks,
Um,
Prathamesh.
See you. Yeah. Bye.